Hi, welcome back to PR Tech Talk. Today we're going to look into ThreadX, and ThreadX is the operating system of Azure RTOS. In the Azure RTOS there are several other parts besides ThreadX. There is the FileX, and there is the USBX, and there is the NetX, sorry. And we might look into those parts as well in the coming videos, but today we're just starting off with the basic, how to get started with the project. And I will start with making just a Blinky without any RTOS at all, and then I will add the RTOS so you can see how you do that in the CubeMX. And I will be looking into the board, the Nucleo H563 board, and that you can also run FreeRTOS on this board, and FreeRTOS is also available in the CubeMX. But I sense that ST is going more and more into Azure than FreeRTOS on the newer releases. The target selector have started, so we choose the tab board selector, and we write what board. Nucleo H563. There we have it. Next. And we give it a name. And now we start the project generation. We get a warning that we need to enable the instruction cache. So I think that we can do that. We just say yes. And then we go for the iCache and we enable that one. We need to then, when we're going to talk about the LED Blinky, we need to find the LEDs where they are. And there are 3 LEDs on this board. And we can take a look on this device here. We have GPIO output on PF4, and we have something on PG4, and we have a third one on PB0. So what we can do here, we can right click on that one, enter username, and we can make that LD1 because that is what it's printed on the silk screen on the board. So now that is named LD1. Now I'm a bit uncertain if this is LD2 or this is LD3, but we gamble. We can be half right. And we just right click on that one and we put LD3 on that one. In worst case, it's wrong. Great, so what I'm trying to do first of all is just to make a Blinky, nothing fancy. So we start with just making the skeleton by creating the project. Like so. I had the reason I did that is that I managed to hide this Project Explorer for some reason. But now we see that we have the ThreadX one here, and under the core we have the source folder, and there we have the main file, which we have here. And this is no fancy stuff. We can come down here to the while one loop, and here we can make our GPIO control space, and then we can write LD control space, and then we can write port pin. That was the LD1 port pin, and then we write LD1, sorry, capital letters, LD1. And we have the pin. Then we remove the rest there. And then we have a small Hall delay. Like so, and we compile the program to see if there is anything. Now when you have done this, you can choose either from debugging or just run the code. We just want to run the code, so we hit this one. And then we get up, since it's the first of launch, it asks us what debugger we want to use. And we would like to use the built-in debugger that is on the board. So we find the serial number there. So now it tries to download the code to the board. And we can see the green LED 1 blinking. And now we can also see if we can manage to get, see if the LED2 was the correct one. That is the next one. So we just do like that. We build it. And we see the green LED is blinking again, but we just hit the run code there. And see what LED is started to blink, if it's yellow or red. So it's the yellow, so that is actually LED2. So we managed to get it right. Super. So this is what we have now. This is a normal project, but now we would like to add a ThreadX, and this is where the special source comes in. So we hit this IOC file again. And we can then look into the sys folder here, and we first of all need to change the time base source. So we changed that to timer 6. And timer 6, and why is that? Because timer 6 is a basic timer. So we don't want to spend those or use those fancy timers just to have a sys ticked. So we changed it to sys timer base to timer 6. That is the first thing we need to do. Then we go down to middleware and software packs. And here we see that we can actually have FreeRTOS if we would like to, but in this case we are going to look into the ThreadX. So we hit that one. And here we can get up the mode, and what I would like to have in this case is just the core, nothing else. Then there are a lot of parameters down here. We actually don't need to handle anything of these just to get the project starting. So we can just build a project. So what we now did, we started first the project without any RTOS at all from ThreadX, and then we just added it onto it from the very beginning. So it's possible you don't need to do it from the very start. You can add it on. I would suggest to do it from the start actually, but you can do it like we did. So we see here is the project, and here we now see that we had a new folder there called Azure RTOS. And we have the include files, and we have the source file, and there we see that we have some more files. We have actually this app threadx.c that is going to be important, and the main C, which we are normally using, it's not going to be as important any longer. But if we stay for the main.c file, and we can see now what's happening here. We have here under user code end2, under that one, we see that here we initialized the MX ThreadX init there. And it says also that we should never get here as control now is taken over by the scheduler. So I'm leaving this code here. So because if this is correct, if I now compile and I haven't made any task, it shouldn't be blinking, right? So I haven't made any tasks, and so we just compile the code. And now we can see, I haven't hit run yet, but we can see the LD2 is blinking. So if I now just hit run, and it's downloading the code to the board, and soon the board is down. So now it's done. I think it's called exit area. So now the code is running, but now the LED stopped. So what did I show with this one then? Well, I showed that that is true. You don't come down to the while loop. From here on, it's taken over by the scheduler, and we leave the main C file. And we now take our interest into this app thread ThreadX.c instead. So here we need to do something to now set up our tasks. And to set up a task, we need to do a couple of stuff. First of all, in this one, we need to have an include for the main H file. And now let's see, we do this here. So we have the main H file there. And then we go down to private defines. Private define there. And then we would make a define on stack size. So we defined thread stack size, and we give it the value 1024. So whenever we write thread stack size, that will be equivalent to 1024 instead. So when we are going to change the size in the coming code, we can just change it here and not in all places. Then we need a couple of variables as well. So we go down here to private variables. I will start by making one task. And that is not a very fancy RTOS, but just for the learning curve. So what we need to do here is having oops, I did some goofy there. So what we have is U integer 8, and we call it thread stack 1, and that means that I'm going to make more stack than this one. So, but this, the first one, is I'm calling the thread stack 1, and the size of that one is the thread stack size, and which is 124 that we had up here. And I also need to have a pointer and to this one, so it's a thread pointer 1. So that is what we need to do there. And now we need also to make a prototype for the file that we're going to make. Now make sure that you take notice of this. Normally it says void with small letters, but ThreadX actually declares that it should be capital letters when it comes in ThreadX. So it's not a typo from my side. It's right. It's void by big capital letters. So void LD1 thread entry, and then the U long also with capital letters. That is also within ThreadX defined. So it's that is correct. I didn't make a typo there. So there is the prototypes. Then we actually need to create the task itself. And this is a long road. So we go down here to uint app ThreadX init, and there is a section called begin and end. So we just open up there, and here we can actually write in our our code for creating a thread. I won't go in details in this tutorial on all this stuff. I will put it in a link in the description below so you can read on it. But basically we have TX thread create, so we create a task. And then we have a pointer to the pointer 1. And that pointer we have up here. And then we just give it a name so we can easily debug it. So you can call it what you want. And you also need to have a thread entry. And this is the prototype that we had here. And we then have this number. This number can be any input, because you see here entry, it requires an input that is a long input. So this is, you can put any number you need. Depending on the task that you do, if that one requires an input value, that is the value you should put here. And then we also need to have the stack, and this is the stack that we declared up here. And then we also need to say what size it has, and the size we declared up here. And then we have priority and preemptive, and we won't go into those parts today, but then we also have the form TX auto start. So as soon as this one has been running, it will create the task for us. But what should we then do? We also need to create some code in it. So we go down here and under user code begin 1. Here you have all your tasks that you are going to write. So I'm writing now the void again with big letters, void. It's no typo, it's correct. It should be big letters. I haven't tried it small, but ThreadX declares that it should be big letters there, or capital letters. And LD1 thread entry. And there you have the ulong in initial input, and the initial input is this number then. And what we go down here, and I just have a while one loop, and here we have the blinky as we did prior. And here we have the blinky LD1, and then we don't use the HAL sleep or HAL delay. We use the TX thread sleep instead. So we tried to compile this one and hope that we have the LD1 to blink. So we hit the run code, and it downloads the code to the microcontroller. And now we have the LD1 blinking. So success, but the LD2 doesn't blink. That is still in the main.c file, so we can actually just take away that code. It doesn't do anything. It will never execute. So there we have the green LED blinking. So if we then just make a couple more tasks, now it's easy. We can just compile or make a copy of these. And we just changed it to LD2. And we toggle the LED 2. This is not rocket science. We give it a longer time. And we call that one LD3. And the reason for me giving different time is just I won't like to have them to blink in different pace. There is actually no impact on it. So now we have made this free task down here, but now we also need to have creating the tasks and the code up here. So we go up where we were from the very beginning, and we double these and two more. And there we have stack 2 and pointer 2. And then we have stack 3 and pointer 3. So you need one stack per task, and you need a pointer per task, and they need to be named individually. So we have those there. And we then also need to create copies of the prototypes. So we copy that one and change to LD2 and LD3, which we named the threads. And we can also, we need to copy this one and change the creation of the tasks. So we go here with changing the pointer to pointer 2, and we can change it to there. I think that you now get a hint what to do here. Like so, and we compile it, and I hope I didn't do anything error here, any problems. It compiled nicely without any errors, and we now then try to run the code again. So it's downloading the code to the board. And there we have 3 tasks blinking in different frequencies. The LD1, the LD2 and the LD3, all running and blinking in different frequencies in 3 different tasks. So I hope that you now have a hint on how to get started with ThreadX, Azure's operating system, and might also look into semaphores and Mutex and stuff also further on, if you find it interesting. And I maybe also would like a similar video on the FreeRTOS, but give me some comment in the comment field if you find that interesting. And if you find it interesting and you learn something, please don't forget to subscribe and give it a thumbs up. And I hope to see you in the next video, and do not forget to hit the round button here below, because that is where you subscribe to my channel. So stay safe till next time. Bye.